Good day everyone, I am Jeremy D. Pandat.
And I am Angel May Casantosan.
And I am Josette Jenna Culiwagon.
And we are here to tell you what Jasp is all about. What's the purpose of Jasp?
And how to use Jasp.
In order for us to analyze our descriptive data that we've got using our software.
Before anything else, let us know what Jasp is. Jasp is crafted with the aim of democratizing statistics, making complex analytical techniques accessible to a wider audience. In addition, Jasp is free of use for everyone.
Whether you're delving into exploratory data analysis, hypothesis testing, Bayesian interference, or conducting meta-analysis, Jasp offers a comprehensive suite of tools to suit your needs. From basic descriptive statistics to advanced modeling techniques, Jasp empowers users to derive meaningful insights from their data with confidence. And in order for you to use Jasp, you should download the Jasp software, and it is free.
In order for you to use Jasp, you should download the Jasp software. It is a very straightforward process. It ensures user can swiftly access its capabilities without unnecessary hurdles. Simply visit the official Jasp website.
So let me share you my screen. So go to any Google Chrome and search for Jasp download, and it will redirect you to this interface. So in this interface, you can see here the Windows, Mac OS, and the Linux operating system. So you can use any of the three, whatever suits you best. But for me, the one using it, I'll be using the Windows operating system since it is the one that I am using. So I already downloaded the file of Jasp software. So after you download it, it will redirect you to this interface. And once you have this Jasp interface, you are going to use a data, or you're going to make use of data from Excel. So I have here a sample Excel file. Here. And this Excel file, it should be saved as a CSV. So in saving a CSV, we're going to click the menu there and save as in this. So put your file name, and again, it should be in a CSV, delimited file, or it must be a CSV, delimited type of file. So let me wait. This CSV, delimited file. So after you click the CSV, delimited type of file, just save it and save as CSV, so that we could use it in the Jasp software. Because if it is not in CSV, delimited type of file, we cannot use it. Save it. Save as CSV. There. So once you it's already saved na, so we're going to Jasp in software. So since we already saved it na, so let's put our data or the file here in Jasp. So put the aring blue and then tap open, or click open rather. Then after that, click the computer and then browse rather, and then here. So here is our file. There. So I have here my data for salaries per week. It has 14 sample data points. And if you want to use Jasp, in order for you to get its descriptive data, click here. For t-test, for ANOVA, mixed models as well, regression, frequencies, as well as the factor analysis. But for the sake of this video, we're going to use descriptive here. So, and since we have here our variable na, salaries per week, this should be click, or we should click descriptives. Descriptive statistics, and then we will transfer it from the left side to the right side of the equation. Click salaries per week, and then there you go. So since we already transferred it, if we want, or you want your data to be an arrow version, just click transpose descriptive table. There, it's in a row now. And while for us to easily all the data, we're just going to use the column type. So para maging column type siya, wag natin i-click itong transpose descriptive table. Yon.
Another one.
So in clicking statistic, we have here a wide range of statistical usage from central tendency, dispersion, inference, quantiles, and distribution. And for the sake of information, we're going to click mean, median, and mode. And also the standard deviation, the mean absolute deviation, the interquartile range, the coefficient of variation, the mean absolute variation robust, and the variance. We're sure going to get the skewness, kurtosis, Shapiro-Wilk test, and the sum of all of that. And also, even its quartiles. In the basic plots, we have here different basic plots. Basic plots here. So in the basic plots, we have here different. For the sake of this presentation, we're going to click for the QQ plots. Next one is for the customizable plots. Customizable plots here. So in customizable plots, we're going to click the box plots. Our scatter plots. So and lastly, we have our tables. In the very bottom, we have our tables. So here in our tables, you can see here we have the frequency tables and the stem and leaf tables. But here we're not going to click for that one. We are just going to click for the stem and leaf tables. Upon clicking everything, the data that you want to get from the sample data that you have, which is this one, it will now redirect you to its answer. So as you can see here, here's are the answers. So nag-click lang tayo, but nag-result na siya to this answer. So na siya, automatic na siya. So we have clicked our descriptive statistics, our box plots, which is both our box plot and QQ plot, and also our stem and leaf plot. So andito na siya. So we have here our. So now let us derive, or let us explain the data for each data that we have gathered. As you can see here, there is a wide variety of data. We have here our valid data, our missing data, mode, median, mean, standard deviation, coefficient of variation, and so on. So this data shown us again that the salaries per week on a sample of 14 data points, this data presents shows us that the average mean salary is 1,892.571, which also is our mean. So yung ating average mean is calculated by summing all the salaries and dividing it by 14. So our median salary is 1,987.500, which means half of the salaries fall below this value and half are above. This value may better represent the data center if there are outliers affecting the mean. While our mode is 1,987, while our mode is 2,280, meaning this salary occurred most frequently in the data. This may suggest that it is the standard or popular wage among this sample.
Nice.
The standard deviation is 482.98, which measures how spread out the salaries are from the mean. Most salaries fall within positive to negative 483 of the average. The interquartile range is 870, calculated as Q3, which is 2,295, minus the Q1, which is 1,425. This range contains the middle 50% of the salaries, showing that half of the workers earn between 1,425 and 2,295. The minimum salary in the data is 1,225, while the maximum is 2,455, giving a range of 1,230. This indicates a wide spread between the lowest and highest salaries. The coefficient of variations is approximately 0.2255, meaning the standard deviation is 25.5% of the mean. This gives a sense of variability relative to the average salary. The skewness of negative 0.316 suggests that the distribution is slightly skewed to the left. This means there are some lower salaries pulling the distribution slightly to the mean. The kurtosis is negative 1.72, indicating that the distribution is flatter than a normal bell curve, which represents platykurtic, with fewer and extreme values. However, it is important to note that kurtosis values negative 1.72, which indicates the data is less peak than a normal distribution. This suggests the data has lighter tails and flatter peak. Still, because of Shapiro-Wilk test returned a p-value of 0.031, we reject the null hypothesis of normality at the 5% level. This means the dataset does not perfectly follow a normal distribution, and any interpretation of kurtosis should be made with caution, especially with a small sample size of 14. So the box plot of the 14 weekly salaries shows the median line at 1,987.50, which is the center of the data. The interquartile range extends from 1,425 to 2,295, illustrating where the central 50% of the salaries lie. The whiskers reach the minimum value of 1,225 and the maximum of 2,455, capturing the full range of the data. Since there are no data points beyond the whiskers, there are no outliers. The box leans slightly to the left, suggesting a mid-left skew due to few lower salary values. However, the relativity show whiskers imply the data is still fairly symmetrical.
A few moments later.
The QQ or quantile plot compare the salary data to a theoretical normal distribution. Ideally, if the data were perfectly normal, all points would lie on a diagonal line. In this case, most of points fall close to the diagonal, indicating the data is approximately normal, though some deviation appear in the lower left, suggesting a few lower than expected salaries. These minor deviations support the Shapiro-Wilk test result that data is close to a normal but not perfect match. Stem and leaf plot interpretation. The stem and leaf plots breaks down the salary data into 1,000 stem and hundreds leaves. Stem 1, 1,000 to 1,499. 4 data points include values in the 1,200 and 1,400 range. Stem 1.5, 1,500 to 1,949. 3 data points includes 1.5, 170s and 190s. Stem 2, 1,950 to 2,449, 6 data points, clustered around 2,000s. Stem 2.5, 2,450 to 2,999, 1 data point, 1 higher outlier at 2,455. This distribution show more values concentrated in the 2,000 range, consistent with the mode being 2,280. The lone data point above 2,450 also match the maximum value of 2,455. This is the data that we need. Again, in order for you to put a data, you should save a CSV file in Excel. Afterward, save it and put it in your Jasp interface. Afterward, you will redirect here and click descriptive. Always remember to put your variable from the left side to the right side and click all the data that you need in your presentation, just like this. Afterward, the Jasp system or statistics software will give you the answer to your data. If there are more questions, if there are more clarification that you want to ask, don't be afraid to ask me and I'll answer your concern. This is Jervik Dipandat, your teacher for today.
So, good day everyone. We are here to do an assessment task, and in order for me to show what that assessment task is, let me share you my screen. So for today's assessment task, we are going to use Jasp. Where's the Jasp? Wait. Okay. We're going to use Jasp or Jasp software. Teka lang, nag-double-double siya. Teka lang. There. So, here's the Jasp for us to solve different statistical problems. But before that, let us know what our task is all about. So, our task is to conduct an independent to conduct a parametric and non-parametric test for significant difference of 2 or 3 or more sample data sets. And we are going to use six different ways to solve 6 different problems. And that is related to solve a t-test for significant difference of 2 to 3 or more sample data sets. So the first problem is on the problem in conducting an independent t-test to determine the answer of research question 1. So here is the research question number 1. Is there a significant difference in the mean of heights in centimeter of section 1 and section 2? And we have here on the right sides our data for the heights of section 1 students and the heights of section 2 students in centimeter. So the first column is for section 1 and the second column is for section 2. So we're going to put it in Jasp software, but we must first put our data in an Excel file and save it as a CSV format file. But since I already have a file or CSV format file, we're going to use now the Jasp and open the said file. So let me open the Jasp. Just wait a minute. Where's the Jasp? It's already gone. So it is. So here is the Jasp. So click this. So yung tatlo ka blue. And then click open. Then computer. Then browse. and then I save it. So once you do it, go where you save the file, just like this. So I save it on the desktop. So as you can see, all of this file are Excel file, but this Excel file are saved in CSV format style so that I could use it in Jasp, because if hindi siya naka CSV format type, hindi mo siya magamit sa Jasp. Okay, so kailangan naka CSV, delimited type of file. Then afterwards, since we're going to use data for the independent sample t-test, so I will click it. So click it and then click open. And charan! Here we have our data. So looking, we have here the data for section 1 and the data for section 2. And now we're going to do our t-test. So first, go to t-test. I'm wrong. Teka lang. So, let's us put first or label the section. So, for us to easily identify the section. So, as you can see, let me label it first. Teka lang. So, I'll double click it. So, here, you should label it. So, I will label it section 1. And then, teka lang. Section 2. Here you go. So as you can see directly, it is changed into section 1 and section 2. Now, we are going to do our t-test. So first, go to t-test. So here's the t-test, and then click the independent sample t-test. So upon clicking the independent sample t-test, let us put our dependent variable, and this is the height. So let us put here, click this, and then for our grouping variable, click section and then click this, so it will turn to the grouping variable. So our dependent variable is the height and height in centimeters of the student, while our grouping variable is the section. So afterwards, so I already check it nga oh. So kunyari wala pa na check. So i-check natin itong student sa my test. And as you can see here, we have our t-test. Negative 1.991. Our degrees of freedom is 22 and our p-value is 0.059. Just looking this one, wala piyok, lapit na lang. So we can see that our p-value is already greater than our alpha value, or the significant value of 0.05. So therefore, just by looking on that part, we can say that we failed to reject the null hypothesis that there is no significant difference in the mean heights of section 1 and section 2 students. Therefore, since we failed to reject it, our conclusion or our interpretation will become there is no significant difference in the mean of heights in centimeter of section 1 and section 2 students. Failed to reject. Therefore, we're going to accept it. But before that, in solving the independent sample t-test, we should also look for the following for our normality, our equality of variances. So let us check this. Let us check normality and then the equality of variances. There. Teka lang. But for this, we're not going to use, as you can see, there is the Brown foresight in the Levins. So, we're not going to use the Brown foresight, but we're going to use the Levins equality of variances. So, let's click this. So, there. So, here's the Levins equality of variances. And lastly, let us click this, descriptives. Oh, click na. So, all of this data can be used. Actually, this independent sample t-test, the assumption checks, and the descriptive. So, all of this data can be used. Again, all of this data can be used in order for us to give an assumption, a decision, an interpretation, in a presentation of the given data. So, using the Levin's test for equality of variances, we can assume that t-test or the variability of each group is not approximately equal, since the significance value or the p-value of the Levin's test is 0.663. Therefore, it can be applied that the variances are equal. So in the normality test, so the p-value is 0.059, which is above or greater than the 0.05 level of significance. Therefore, we fail again to reject the null hypothesis. It can interpreted that there is no significant difference in the mean heights in centimeter of the section 1 and section 2 students, as we fail to reject the null hypothesis. Therefore, in using a 7th edition format or APA presentation of results, we can say that results or the tables or the given data revealed rather that the t-test failed to reveal a statistically significant difference in the mean heights in centimeter of section 1, which has a mean of 116.167 and a standard deviation of 13.895, and the SE, which is the 4.011, the coefficient of variance is 0.120. For the section 2 naman, we have the mean of 1.127 rather, 0.833. For the standard deviation, we have 14.801. And for the SE is the 4.273, as well as the coefficient of variation is 0.116. Where our alpha value is 0.05. So that is an example, but since our p-value is 0.05, kasi ayun nga, we fail to reject the null hypothesis because the alpha level or the significance level is 0.05. So that is an example of using the t-test. Again, in solving t-test, check the following in the Jasp software: normality, equality of variances, and your descriptives. That is the most important thing in order for us to properly interpret data in solving independent samples t-tests, since we are done already in computing or using independent samples t-tests in answering the research question number 1. Now, let's proceed to another test and another example.
Okay, let's go.
So now, in this part, we're going to conduct or to use a Mann-Whitney U-test in determining the answer of research question number 2. So, is there a significant difference in the average mean of objects recalled by the participants in the sleep group and no sleep group? So, just like the first question, on the right side, we have the no sleep group, and on the left side, we have the sleep group. So on the sleep group, it will serve as our 1 or data number 1, while for the no sleep group, this will serve as the group or data group number 2. So, and for us to solve that one, again, we're going to use the Jasp software. So to find our file, we're going to go to Open, Computer, and Browse. So these are the list of the Excel that are saved in CVS. So we're going to find the Whitney U-test. So as Angel said earlier, we use data. We group the data in 1 and 2, where 1 is the sleep group while the 2 is the no sleep group. But here, in using Jasp, we can rewrite the value of our labels with the corresponding label. Again, group 1 is the sleep group, while the group 2 is the no group. So here is the sleep group, while the other one is the no sleep group. So now, we are tasked to know to use man-Whitney U-test using Jasp software to solve this problem. So now, in doing the man-Whitney U-test, we're going to first click the t-test, the same click independent samples t-test. So, but instead of checking the student, we're going to use the man-Whitney, and afterwards, you're going to the same goes our dependent variables, of while for our grouping variables is the sleep and the no sleep group. So the object recalled is for our independent, while the group is for our grouping variable. So by putting that, we can see that our p-value is 0.256, while our man-Whitney is 92.00. So we can see that our p-value is greater than 0.256. Therefore, again, since it is greater than our significant value of 0.05, we can say that our data, again, failed to reject our null hypothesis. Therefore, if our research question earlier is there a significant difference in the average mean of objects recalled by the participants in the sleep group and no sleep group, we can conclude that since we failed to reject the null hypothesis, we can say that there is no significant difference in the average mean of objects recalled by the participants in the sleep group and the no sleep group. Again, greater than, we fail to reject the null hypothesis, accepting it. Therefore, we can say that there is no significant difference in the average mean of objects recalled by the participants in the sleep group and no sleep group. But students, be mindful that aside from having this table, you should also go to your descriptives, where variables will be objects recalled while you're going to split it in a groups, like this. And group is splits. So in this statistic, we're going to check for the mean, median. We're going to check for your mean, standard deviation, the maximum and the minimum, the skewness, kurtosis, Shapiro-Wilk. So aside from that, we're also going to cut it into 4 equal groups to get our percentiles, which is the 25th, 50th, and the 70th percentile. So quartiles, cut points, 4, 4. So like that. So wait, we're going to check So we're going to check the median for your mean, standard deviation, the maximum and the minimum, the skewness, the kurtosis, Shapiro-Wilk, and also cut points for 4 equal groups, where we're going to get the 25th, 50th, and the 75th percentile. And by having this two data for our descriptive statistic and independent sample status, we can do an assumption, a decision, or an interpretation, and a presentation in the use of 7th edition APA format. We can assume that the man-Whitney U-test can assumes that the data comes from 2 different independent groups. In this case, objects recalled are the data and the 2 groups, which is known to be the sleep group and the no sleep group, are presumably independent. So there are independent or or basically they don't have any relations. So in deciding, or we can make a decision that a man-Whitney U test statistic is 92 with a significant value of 0.256, and since our significant level is typically set at alpha 0.05, we fail to reject the null hypothesis. The results of the Mann-Whitney U test do not provide statistically significant evidence to conclude that no sleep group has a number of recalled objects than a sleep group. There may be no difference in the median scores between the sleep group with the median of 11.5, as you can see 11.5 here, and 9 respectively, and the Mann-Whitney U test value of 92 and p-value of 0.256. Since now we are done with the first and the second problem, we can now proceed with our third problem.
Okay, since we are done already with the first three questions, now let's proceed with the use of Wilcoxon sign drop test in answering the question. Is there a significant difference in the water intake before and after the injection of hormone Y? Again, the same goes with the paired sample t-test. We have here our before and after of the injection data, and it's about the same respondents. Then again, using the Jasp software, we're going to open or to encode our data in the Excel file and save it in CSV. And now we can open it here. Again, that is an Excel file saved as a CSV file. Don't save it as an Excel file. It should be a CSV. We have here already our data for the before and after injection. Same goes, we're going to proceed with paired samples t-test. And we're going, and we're going to put again our paired variable before and after the injection. But then again, aside from checking the Wilcox ID student, we're going to use Wilcoxon sign drop test. And we can see here our Wilcoxon sign drop value 3. The z-test of negative 3.361 and our p-value of less than 0.001. Aside from that, we should also check for our normality, which is on Shapiro-Wilk. Okay, this one, our normality. And aside from that, in using data or in interpreting data from Wilcoxon sign drop t-test, we're also going to use our descriptives. Put both here and go to statistics. Upon going to statistics, we need to get rid of everything and just leave the median and the percentile rounds. Okay, we're going to put the median and the percentile rounds were cut into 4. Okay, there. Waiting for our data, there we have now our medium of 0.650, which is again, always remember that it's only the same with our 50th percentile. But for the sake of this, we're going to use all the data. We have now our measure 1 of before injection and measure 2 of the after injection with our Wilcoxon rank sum value of 3. Z value of negative 3.361, our p value of less than 0.01. As you can see here also in the normality assumption, checks on the test of normality using the Shapiro-Wilk. We have our value of 0.617 and a p-value of the same 0.001. Also students, be reminded that in making use of this data, we can interpret, make a decision. We can also assume and present the data given. Our assumption here is that the dependent variable measures at an ordinal or continuous scale. It consists of categorical data. And there is a difference between the water intake before and after the injection of hormone Y, as you can see here. So the decision, the Shapiro-Wilk test indicates a non-normal injection of hormone Y. And the distribution of water intake both before and after the injection with a p-value of less than 0.001, which is less than the significance level of 0.05. The Wilcoxon ranked some test result between the water intake before and after the injection of hormone Y. Since it is less than, we are going to reject our null hypothesis. Once again, we're going to reject our null hypothesis. Okay, therefore, there is no significant difference between the water intake before and after the injection of hormone Y. It is then implied that there is a strong reason to believe that the injection of hormone Y had a significant impact on water intake, while the normality assumption for a paired sample t-test might be violated here. The highly significant Wilcoxon rank sum test provides strong evidence that the water intake after the injection of hormone Y is statistically different from the water intake before the injection of the said hormone. Therefore, a Wilcoxon sign rank sum test indicates that the water intake after the injection of hormone Y was statistically significantly higher than the water intake before the injection of the said hormone. With our value z-value of negative 3.361 and a p-value which is less than, as you can see here, it's less than 0.05. A Wilcoxon sign rank sum test indicated that the median of the water here are the water intake here after the injection of hormone Y was statistically higher than the median of the water intake before the injection of the said hormone with median of 10.950 and 0.650 respectively. With our z again of negative 3.361 and a p-value which is less than 0.05, we are done here with the fourth problem. And using the four different ways, we're going to proceed with the fifth one, which is about the ANOVA.
And the third problem, we're going to use a paired t-test to determine, or paired sample t-test to determine the answer of research question. Is there a significant difference in the mean of amount of material learned between the new method of instruction and the standard instruction? As you can see here, we have our pair number 1 to 20, and we have here our new method and the standard instruction. Data for the new method is for the first column, while the standard instruction will be put on the second column. And in order for us to solve this one, again, we're going to open a Jasp software. You click the open, go to computer and open your browse. Then click your file. But if you have here your files already, you can check it here, and we have our data for the paired sample t-test. And open. And we have here our data. We have here our data for the paired sample t-test. The new method, we have here the new method, and the same goes for the standard instruction. Always remember that in using paired sample t-test, the participant in the first column are the same with the second column, and it is just difference in their score. Now let's proceed. Go to the t-test, click the paired sample t-test, and our new and the standard instruction. Just remain with our p-value here, and using this one we can see our t-value of 1.0 826, our degrees of freedom of 19, and our p-value of 0.084. Since our p-value is again greater than, greater than our significance value of 0.5. We can directly say that with per sample t-test, we can conclude that there is no significance difference. Is the mean of amount of material learned between the new method of instruction and the standard instruction. But then again, wait. But then again, always remember, student, that aside from clicking the paired sample t-test, we're also going check for the assumption check. Assumption check. Which is the test of normality in our descriptive and we need all this data in order for us to make an assumption, a decision, an interpretation, and a presentation of result. First, again, our research question here is there a significant difference in the mean amount of material learned between the new method of instruction and the standard instruction? Having asked to have a null hypothesis of there is no significant difference in the mean of amount of material learned between the new method of instruction and the standard instruction. As you can see here, we can make an assumption that the total paired sample t-test assume the difference between the mean amount of material learned between the new method of instruction and the standard instruction. We can make also a decision that the mean amount of material learned is the new method of instruction with a mean of 81.75. And the standard deviation of 7.677 is greater than the mean amount of learned material in the standard instruction with a mean of 78.65, and the standard deviation is 7.625. The probability of value of 0.60. So for the null hypothesis, p-value is greater than our alpha of 0.05 level of significance. Therefore, again, we fail to reject the null hypothesis as we have our t-value of 1.826. With a degree freedom of 19 and another p-value of 0.084 greater than the alpha value of 0.05. This information can be interpreted that there is no significant difference in the mean amount of material learned between the new method of instruction and the standard instruction, as again, we fail to reject the null hypothesis. Therefore, a two-tailed paired sample t-test revealed that the mean amount of material learned is the new method of instruction is not significantly different compared to the mean amount of material learned in the standard instruction. Since we are done already with the first three questions, now let's proceed with the use of Wilcoxon sign drop test.
So now we are done with our fourth question. We can now move to our question number 5. It is to conduct the ANOVA test. So in this experiment, 18 cocaine addicts were randomly assigned to one of the 3 groups of 6 addicts per group. All groups received counseling over the 10-week treatment period plus the treatments. These experiments wanted to determine if there are significant differences between the number of cocaine urges by the participants assigned in the 3 groups. So for group 1, we have the acupuncture plus counseling, placebo plus counseling, and relaxation therapy counseling for group 3. So now, in order for us to solve this statistic, we're going to the Jasp. So from here, we're going to go to open computer and browse and look for your file. So again, reminding everyone to always save your Excel file to CSV. So, wait, we're going to find for our ANOVA test here, this one. So now, for our data, it was presented here, group 1, group 2, and group 3. So, in order for us not to be confused, we're going to name our groups. So, for our group 1, we have the acupuncture, plus, plus counseling. Next is the placebo plus counseling. And of course, for the last is therapy. Wait, let me check. Or relaxation therapy counseling. Relaxation therapy. Relaxation therapy plus counseling. So now that we have already wait. Relaxation therapy plus counseling. So now, let's see. So now, for us, we can solve for its ANOVA. So go to ANOVA. And here, group of cocaine, 2 dependent variable, and of course, group for fixed factor. So just wait for its being generated. So let's just wait for a moment. Let's move it up. Okay. So now, as you can see, the sum of squares for group is 80.111 with a degrees of freedom of 2 and 15 for the residuals, which is the sum of squares is 70.33. So our F value is 8.543 and our P value is 0.003. So as you can see, it is less than our alpha, which is 0.05, which means we can conclude that there are no significant differences between the number of cocaine urges by the participants assigned in the groups of acupuncture plus counseling, placebo plus counseling, and of course, the relaxation therapy plus counseling group. But then again, in using ANOVA, it does not stop there. So again, we would look for our descriptive statistic, which is here at the bottom. We're just gonna click the descriptive statistic or check the descriptive statistic. And then here, we can see that for the N, we have the 6. So, lahat siya 6. But for the mean, we have 4.500, 9.333, 8.500. So, for the SD naman, standard deviation, we have 1.871, 1.966, and 2.588. So, aside from that, we're going to check for our assumption checks, which is here. we're gonna check for homogeneity test. So it's been generated. Let's wait for a moment. So now, here is it. So aside from we use assumption checks so that we can get our Levin score of degrees of freedom 1, which is 2, and degrees of freedom of 2, which is 15. And the p-value of 0.426. So aside from that, directly go to post hoc test, which is nasa baba rin. Here, post hoc test, where we're going to put the group into the other side, just like that. So lastly, we can go to our descriptive. So in our descriptive, the number of cocaine will be in the variable while the group will go to the split. So descriptive, here, descriptive, the group of cocaine is for the variables and the group is for the split. So it's being generated. So let's just wait for it to be generated. So using all of this data, we can make a decision, an interpretation, and the presentation of data using the 7th edition style. So in making a decision, we can say that the descriptive here shows that among the 3 groups of the placebo plus counseling group, the 3 groups, placebo counseling got the highest mean score, while the acupuncture plus counseling has the least or lowest. So the mean, the homogeneity of variances shows that the significance value of the Levin statistic here, which is in this part, based on comparison means of 0.426, which is here. This is not a significant result, which means that the requirement of homogeneity of variance has been met, and the ANOVA test can be considered to be robust. So the F value of here, which is here, is the F value of the F value here, the ANOVA, the F value is 8.543. Okay. While our p-value is 0.003, which is again less than the alpha value of 0.05. This means that there is no significant differences between the number of cocaine urges of the 3 different groups: acupuncture, placebo, and relaxation therapy. Aside from that, the Tachyana significant differences shows that its means difference between the acupuncture plus counseling group here and the placebo plus counseling group are both significant, since the p-Tachy here, p-Hope test values is less than the significance values of 0.5 here, the p-Tachy. So kung makita natin, all the groups is less than 0.05, which shows that there is no significant differences in the test scores that have gathered here. The analysis also revealed that significant difference in the test scores across the 3 different groups, with the highest mean here, and the descriptives wait. So to interpret the given data or the data, we have gathered here analysis to reveal that the significant difference in the test scores across the 3 different groups with the highest mean Here, the highest mean or of cocaine urges is the placebo. Placebo plus counseling. So, ito ang pinaka-highest, which garnered 9.333, while the acupuncture plus counseling garnered 4.500, which is the lowest mean. So there's no conclusive evidence that the first group differs from the other based on the current analysis. Thus, we can say that there was a statistically significant difference between the group as demonstrated by one-way ANOVA. Ataki post here showed that the acupuncture plus counseling group was able to obtain higher number of cocaine here than those the placebo plus counseling group and those under the relaxation therapy plus counseling group. So there was no significant or statistically significant difference between the number of cocaine urge of those under the placebo and the relaxation, with the p-value of 0.786 respectively. Since we are done already with the use of the 5 different ways, we can now proceed. So now, we are done with the 5th. We can now proceed to the crystal wall list.
Since we are already done with the use of the 5 different ways, let's proceed with the conduct of Kruskal-Wallis H test. So let's go to the PPT. Wait. There. So in answering the research question, an instructor conducts an experiment to evaluate if there is a significant difference in the 3 exam versions in terms of difficulty. So the results are given in the table at the right side. So in making a statistical question or research question in this one, we can say that there is a significant difference in the 3 exam versions in terms of difficulty. And with that, we can have a null hypothesis, HO, stating that there is no significant difference in the 3 exam versions in terms of difficulty. And in order to know if that specific null hypothesis is true or not, let's use the Jasp software and answer the problem. So let's open the Jasp. Let me go to the Jasp. Wait. Okay, teka lang. Let's go to the Jasp. There you go. Wait. Okay, just wait a little bit kasi hindi pa siya nag-load sa Jasp. Teka lang. Okay. So, this is the Jasp interface. Always remember that everything you put into Jasp, dapat naka-CSV, delimited file siya. So, para ma-put siya dito. So, let's open the file. So, let's find where is our Kruskal-Wallis H test. Teka lang. Nagalagers ito. Nagalaglag ang laptop. Teka lang. Yeah. So, I will wait. I will click this. And there you have it. Charis. There you have it, ladies and gentlemen. Ito na po yung file. So, we have here our scores and the exam version. But again, directly go and rename the given file or labels to your files that like this one. So, you double tap it like this. Then, put version 1. teka lang, version 1. And then, version 2. And then, version there. So, as you can see, in order for us to know directly each version, as you can see, there is already na kasi giset man natin, gilabel man natin. So, madali na siyang ma-identify ang version 1, version 2, version 3, and so on and so forth. So, now we're going to use ANOVA. And the ANOVA is here. Like there, you click the ANOVA. And then, there you have it, ladies and gentlemen. So, our exam version is the fixed factors. Am I right? Yeah. So, exam version is the fixed... mali ako. Sorry. So, our exam version is dapat, ito siya yung... teka lang. Paano ito? Teka lang. Then, so, ang exam version is yung ating dependent variable and our fixed factor is yung group. So, aside from that, we're going to go to our descriptive. So, tayo, swipe down. Yeah. So, makita ninyo dito, may display. So, i-click yung descriptive statistics. Yan. Kita na yung descriptive statistics. So, we also have here our ANOVA with our cases exam version in the residuals with a p-value of 0.749, indicating that it is greater than the significance value. Therefore, just by looking at that, since it is greater than, we say we are going to reject the null hypothesis. Therefore, we can say that there is really a significant difference in the version 3 exam or the 3 exam versions. But before we're going to give a decision or an interpretation in a presentation of the data, let us give all the data needed for that. We now have our ANOVA. So we also have our descriptives. As you can see, so now let's proceed to our assumption. Let's proceed to our assumption checks. Let's click it and then click for the homogeneity test. And then afterwards, directly go to post. Directly go to post HOC. Okay, ito. Post hoc test. Like that. And then, put your exam version. So, where's the exam version? So, put your exam version here on the post. Teka lang. There. So, put your exam version there. And then, it's not the model actually. It's in the lower part, non-parametric. And wait. So, ito na yung sabi dito, i-click natin yung post hoc test and then under ng post hoc test, i-click natin yung ating exam version or yung group, ilagay natin dito. And then after that, it is the post hoc contrast. No, it's not the contrast model. It's not the model. It's in the lower part, non-parametric. They're non-parametric. For the non-parametric, it will give the Kruskal-Wallis test. So here, please be reminded that in order for you to check the Kruskal-Wallis, go to non-parametric. So let's find the parametric, non-parametric. Ito. Let's go to the non-parametric. And then, you can have, or teka lang. So, you can get this one. Let me reiterate so that we will not be, we will have again ANOVA. So, put your dependence variable. Put your dependence variable and your fixed factors. Then check. Teka lang. There. And then, check for your descriptives. Directly go to your assumption checks. Teka lang. Let's go back to our assumption checks. There. And then, check for your homogeneity. Where's the homogeneity? There. So that you can get your assumption check where the test variance, and lastly go to the most lower part and go to the non-parametric, and you can have your Kruskal-Wallis by putting your data on the right side part. And now using the given data, we can now make a decision that the test statistic Kruskal-Wallis, which is roughly 0.586. Teka lang. Ito, makita nyo man sa statistic, it's 0.586. Indicates difference between the groups being compared. Moreover, it turns out that the differences in difficulty is not statistically significant. The value of P, which is 0.746, basically means that there's a 74.6% of finding sample results if exam version does not have any effect in the population at large. If a participant does nothing, it has a big chance, which is 74.6% of finding such difficulty, lowering differences because of random sampling. But always remember, if P or the P value is less than 0.05, it is usually concluded that the differences are statistically significant. We can interpret this that the results suggest that the exam version may have a noticeable impact on the difficulty level of the Kruskal-Wallis test statistics that indicates no significant differences between the groups and the high p-value of 7.7 or 0.746 rather. It tells us that it's likely that this difference happened by chance. In other words, there is a weak evidence that the exam version is linked to difficulty level in the population studied. Therefore, a Kruskal-Wallis test showed that there was no statistical difference in the difficulty level in the three exam versions. The Kruskal-Wallis, the versions with the Kruskal-Wallis test. So the statistics of 0.586 with a p-value of 0.746 with a mean difficulty. So let's find the mean difficulty. Teka lang. With the mean. With the mean difficulty of 76 for version 2, 78 for version 1, and 82 for version 3. Now, we have solved each problem given in the assessment task. So, the first one is in the use of independent sample t-test. Teka lang. So, ito. Wait. Let me bring you to the PPT. So, actually, diba, so from the start, it is said that we have to solve 6 different problems in 6 different ways. So, the first one, teka lang, it's Lagrange. Wait lang. There. Wait, palakihin ko muna. Ito. So, the first one, it is in the use of an independent t-test to determine the answer for research question number 1. Ito pala, sorry. So, ito yung unang yung tinest natin, yung parametric and or the independent t-test. Teka lang.
So the first one rather is in the use of independent sample t-test. The second one is the use for yung Whitney U-test. And the third one is yung paired t-test. And the next, the Wilkerson signed rank test. And the last one, yung ANOVA test. Ay, actually meron pa pala, sorry, itong last one, yung Kruskal-Wallis H test. So, since it is the fifth, so it is the fifth for the ANOVA, or I mean, it is the last, rather, or it is sixth, it is the Kruskal-Wallis H test. So, each test signifies the conduct of parametric and non-parametric tests for significant difference of 2 to 3 or more sample data sets. So, yung sinabi ko kanina na 6 is ito yung para sa parametric and non-parametric test. Para ma-determine kung meron ba siyang significant difference or wala sa within 2 or 2 to 2, I mean 2 to 3 or more sample data sets. So, that's for today. Students, that's it. Thank you very much for listening to us. So, if you have more questions, feel free to ask the four of us, Charis. So, feel free to ask Jervin Pandat. Ay, oo.
Okay.
Okay.
Yung last na itong dito.
Okay. Bye.
Once again, this is Jervic D. Pandat,
Angel May Kasantosan,
Hans Oriel F. Catalan,
Josette Jana Kiliwagan,
and we are your teachers for today.